All right, part 2. So we've already talked about the first 7 steps minus step 4. We'll talk about that next time. So last step, step 8. So step 8 is basically finding your conclusion, right? Okay, you got reject or fail to reject. Now what? Right? You can't, if you were a statistician, for instance, and your boss said, hey, does the XOR method work? Right? Well, you can't go back to them and say, hey, you know what I found out? I rejected that null hypothesis. Right? They're not going to have any clue what you're talking about. So the conclusion basically just puts it back into human words for the layperson, right? The person who doesn't necessarily know anything about math. Not like us. We actually know this stuff now. Good. So one hint is that it should definitely start with the words, there is sufficient evidence to conclude whatever, or there is not sufficient evidence to conclude whatever. Good. So the first one, if you say that there is sufficient evidence, it's because we rejected the null hypothesis, right? Remember, the null hypothesis was our assumption. So if we reject it, then there was sufficient evidence, right? There was definitely enough evidence to prove whatever we were trying to show. Likewise, if we fail to reject the null hypothesis, it's because there was not sufficient evidence, right? Whatever you were trying to show, not enough evidence to show that. All right, and whatever this part is, typically comes from your HA. So we should be using our HA, and then the HA we can basically, right? So remember, step 1 was turning the claim into math, and then step 2 was the counterclaim into math. So basically step 8 is going to be going backwards, taking the math and turning it into either the claim or the counterclaim, depending on what our HA was. And they already gave you the words for these, so hopefully it'll be okay. Also, remember, we are not proving our null hypothesis. We are not proving our null hypothesis, right? Fail to reject says more correctly that the available evidence is just not strong enough, right? So maybe the XOR method actually does work, but as of right now, we need more evidence, right? There's not sufficient evidence. That's why we write it the way we do. All right, so let's go back through these examples that we've already gone through. Number 3, and now we're going to just state what the conclusion is. So part A, we said our conclusion was that we failed to reject. So since we failed to reject, was there enough evidence? No, there was not. So we say number 8, there is not sufficient evidence to conclude that. And then let's look at it. So our alternative hypothesis, our null hypothesis was this, and we actually are going to keep this, right? Because we don't reject it, which means that this is what there was not sufficient evidence for. All right, our HA. So mu is less than this giant number. So what does that mean? Well, since this is the same as our claim, we can just rewrite what the claim was, right? The claim said the real estate believes that the mean price has decreased since then. So we can say there's not sufficient evidence to show that the mean price has decreased since then. Done. Easy. Part B. All right. So step 8. So we rejected the null hypothesis. So is there enough evidence? Yes, we could reject it. So there was enough evidence to show something. There is sufficient evidence to conclude that. All right. So we rejected the null hypothesis, which means that we are keeping this statement. So what was there enough evidence to conclude? Well, again, if we look at it, right, the alternative and the claim are the exact same in this case. So we can conclude the claim. What was the claim? The percentage has increased since then. So there is enough evidence to conclude that the percentage has increased since then. Or if you wanted to use something a little more specific, right, we could also say there is sufficient evidence to conclude that the percentage is more than 12.8%. So you could do it either way, right? You could either use part of the claim or you could just rewrite this in word form. All right, part C, step 8. So we rejected. So is there sufficient evidence? Yes, there was. So there is sufficient evidence to conclude that. All right, so we reject the alternative the null hypothesis, so this is what we are keeping. And we can see this time that it's the same as the counterclaim. So basically it's going to be it's going to be the opposite of our claim, right? So if we look at our claim, the claim says the mean price hasn't changed. So the opposite of that, the counterclaim, is going to be that there wasn't enough evidence to prove that the mean price has changed since then, right? So basically what's happening is that because we always want our alternative hypothesis to be the does not equal to, right, does not equal to, less than, or greater than, sometimes it's not going to be the exact same thing as your claim. So by the way that we are doing this, we actually weren't proving their statement. Their statement was our assumption. We were trying to prove that it actually was changing. And there's other ways of doing this, but this is the best way of doing it. Making sure, I mean, ideally, right, if he would have claimed, or she would have claimed, whoever this person is, the real estate broker, always trying to claim the does not equal to, less than, or greater than statement, then it might make things a little easier on that person. But anyway, yeah. So there actually was enough evidence to conclude that it has changed since then. So not great. Their assumption was incorrect. Last one, part D. All right. We failed to reject, so we would say that there is not sufficient evidence to conclude that. So we're going to keep our null hypothesis, which means what was there not enough evidence to conclude? Well, in this case, HA is the same as our claim. So we can just rewrite the claim, right? There wasn't enough evidence to conclude that the majority of adults file taxes through an accountant or other professional. So maybe it is true, but from what we saw, we needed more evidence, right? There's definitely not enough evidence to show that. All right. So hopefully those 8 steps made sense, minus step number 4. Like I said, the next 2 sections, we're just going to be doing this over and 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 over again. So as soon as you get all 8 steps down, this stuff is going to be super easy. And if you don't have it down now, like I said, the next sections, we're going to be doing it over and over again. So it'll be good practice. All right, type 1 and type 2 errors. So sometimes we can make mistakes, right? Our decision might not be what reality actually states. And the hard part about this is that sometimes we don't actually know what this is, right? So just like with the, what we talked about with the confidence intervals, right? Sometimes we don't know what the actual percentage is or what the actual mean is. So that's why sometimes it's a little hard for students to understand. But we can still make an error even if we don't know we're making an error. So here's how we do this. So this is the way that I like to write it out. Just this nifty-difty chart. All right. So we have two decisions, right? We can either fail to reject the null hypothesis or we can reject the null hypothesis. And then we have reality. Either the null hypothesis was true or the null hypothesis was false. So these are the two different ways that we can do stuff. So if we failed to reject the null hypothesis and the null hypothesis was true, did we make a mistake? So the null hypothesis was true and we failed to reject the null hypothesis. Did we make a mistake? No, right? We said, hey, there's nothing better out there, and there isn't. It was actually true, so no mistake was made. Yay! All right. What if we rejected the null hypothesis? Oh, wait. Yeah, so let's write that down. So number one, failing to reject the null hypothesis when the null hypothesis is true, this would be correct. All right, rejecting the null hypothesis when the null hypothesis was true. So we know that the null hypothesis was true and we rejected it. Did we make a mistake? Yeah, we definitely did, right? And so what we call, that would be a type 1 error. So that would be incorrect, right? We have done something incorrect, and that would be a type 1 error. So a type 1 error means that you rejected the null hypothesis, but the null hypothesis was actually true the whole time. Next, what if you failed to reject the null hypothesis and the null hypothesis is false? So the null hypothesis is false, and you failed to reject it. Did we make a mistake? Yeah, we did, right? We should have taken the alternative hypothesis because it is not true. So this is what we call a type 2 error. My computer's not wanting to work. There we go. All right. So we failed to reject, but the null hypothesis was true. Or sorry, when the alternative hypothesis is true. Well, that's not the best way to say it. When the null hypothesis is false, then the decision would be incorrect. And we have a type 2 error. Oh my gosh, this is not great. And then lastly, if we reject the null hypothesis and the null hypothesis is false. So the null hypothesis is false and we reject it. That's good. We did the correct thing. So hopefully this table can help you remember what a type 1 and type 2 error is. This is honestly how I have to do it. I just have to rewrite this table when I'm doing a problem like this to remember, wait, which one was which? Good. And so then, of course, we say that if we reject the null hypothesis and the alternative hypothesis was true, or the null hypothesis is false, right? Both ways, then that would be correct. All right, so here we go. So let's go back to problem number 3. This is the last thing we got. We're just going to go through this one more time, and we're going to determine the potential errors and how to fix it. So what kind of error could we have made? Now, it doesn't mean we necessarily made an error, but if we did make an error, which one would it have been, and how do we fix it? All right, so for part A, we failed to reject the null hypothesis, right? We failed to reject. So the potential here, right, if we go back to our table, the potential here is that if we failed to reject, we made a type 2 error, maybe, maybe we made a type 2 error since we failed to reject. So if we did make an actual error, how could we have fixed it? So we should have, so if we made a type 2 error, right, if we failed to reject, then we should have rejected H naught. We should have rejected it. Now, how could we have rejected it? So if you go back and think about this, when do we reject things? When do we reject the null hypothesis? We do it when the p-value is less than alpha. But in this case, right, the p-value was greater than alpha. Now, we can't change the p-value. That's the probability of what we actually observed. So that's stuck in stone. But we can change our significance level, right? So if our p-value was 0.049, what could we change the significance level so that it would be less than, so that way we would have rejected it? Well, you can see that we could have changed it to 0.05, right? If our significance level was 0.05, then we would have rejected the null hypothesis. So how can we fix it? We could increase alpha to 0.05. And that's it. All right, let's look at part B. So we rejected the null hypothesis, right? So if you go back to our table, I'm scared to go back. I don't want it to mess up again. Okay, cool. So we go back to our table, right? If we rejected the null hypothesis, then the potential was that we have a type 1 error. So how do you fix it? So what should we have said? We should have failed to reject the null hypothesis, right? We should fail to reject instead. Which means that our p-value should be greater than it, right? The p-value in this case was 0.0. 0.038, and the significance level was 0.10. So what could we change our significance level so that way this would be bigger? Well, not 0.05, but we could change it to 0.01, right? So how can we fix it? We could decrease alpha to 0.01, right? That could fix it. And again, we don't necessarily know that we made an error, but if we did, this is how we could fix it. Part C. So we rejected, so just like the last time, right? That's the potential for a type 1 error. So we should fail to reject. If we made a mistake, instead of rejecting, we should have failed to reject. Which means that the p-value should be bigger than our alpha. So if the p-value was 0.002, then we should decrease alpha to about 0.001, right? Just something smaller than that. It really could be anything, but something smaller than that. So we could decrease alpha to 0.001, right? Because then p-value will be bigger, so then we would fail to reject. All right, part D. So we failed to reject, so that is a type 2 error, potentially. So to fix it, well, let's go back. What should we have said? We should have rejected the null hypothesis. So p-value is 0.34. So that means that if we rejected it, then the p-value has to be less than our alpha. So we just need to find an alpha that's bigger than 0.34. So we could have 0.50. We could have 0.40. We could have 0.35, right? Super doesn't really matter. Just as long as it's bigger than our p-value. So we could increase the significance level to 0.50. All right. Now, last thing, I promise, and then we're done with this section. Are any of these likely that we made an error? So is it likely that we made an error? Let's just go backwards, right? So for this last example that we just talked about, remember, the significance level is the cutoff for unlikely. 50% is kind of a big number for unlikely, right? If the p-value is 34%, if it is likely to occur by 34%, that's pretty likely, right? So to have a cutoff point that's so big, we probably did it correctly. Probably no error, right? Because 34%, regardless of what your significance level is, that's a pretty high percentage. Let's look at this one, right? In this case, the p-value was 0.002. Again, regardless of what your significance level is, that's pretty unlikely. Right? If we do that in percentage form, that's 0.2%. That's less than 1%. That's pretty unlikely to occur. So we probably did it correctly, right? It was probably rejecting. So, hold on a second. There we go. So again, there was probably no error. Let's keep going backwards. So part B. So we said that the value was 3.8% for significance level. Maybe. There might have been an error. So the most common values for your significance level is 0.01, 0.05, and 0.10. If you notice, for the confidence level, that goes with 99%, 95%, and 90%, which are the three most, important ones that we typically use, the most common ones. So 10% to 1%, these are pretty much the most common. So since there was an option for 1%, we might have actually made an error. It's potential. And likewise, right, with this one, this was almost 5%. So that really could have gone either way as well. Yeah, so maybe an error. It's potential. Potentially. Cool. All right. Well, like I said, the next two sections are basically just going to be going through those 8 steps over and over again. If you have any questions, like always, you can email me or text me. Have a great day.